Well, welcome to the second module on forecasting. What we're going to cover today is satellite information. In the previous module, we covered surface features such as fronts, high pressure, low pressure, and now we'll move on to cloud cover and some things that we can infer from what we call satellite imagery. This is the Unisys site, and what we're doing right now is we're going to look at a 12-hour loop of infrared satellite imagery. And you can see the general movement of the cloud patterns is from west to east. I'm going to identify Iowa here with the cursor and notice that some of the whiter areas, which indicate cloud cover, over just to the north of us in Minnesota, and then back here in the southwestern portion of the U.S., and then we have more cloud cover coming in from the northwest. So as I sit here on a Wednesday evening over Iowa, there's not too many clouds out here. There's a little bit of middle clouds moving into Iowa. But it looks like as we head into the next day, we can expect to see some cloud cover moving in. So if you were forecasting for Des Moines, Iowa, you would probably venture in your forecast to say that cloud cover will be present, probably tomorrow. We see also some cloud cover down in the southeastern portion of the U.S., but a large portion of the central and southern plains is cloud-free. So, if we were to go back and look at a surface map, recall the surface map is where they have all the low pressures, high pressures, fronts. There's probably some sort of weather system out here where I'm outlining with the cursor, and probably some sort of weather system down here in the southwest, and probably a weather system up here in the Pacific Northwest. So let's just go to the Unisys homepage. And the first map we see here is a surface map. And sure enough, you see what we call a cold front back here associated with all of these clouds. Okay, so near the fronts and near the low pressure systems, we have a large area of cloudiness. Notice over here in the southeastern U.S., we have high pressure. And typically with high pressure, you see clear skies, fair weather. Now, notice how I'm moving the cursor. I'm moving the cursor clockwise around the high pressure. That is the wind flow around high pressure. So, where would you expect the winds to be coming from in Iowa? I'll try to slow the cursor down. The winds are coming from the south. And we do wind direction by where the winds are coming from. So we have a southerly wind. So by looking at the surface map, I can predict our wind direction, or at least I can surmise where the wind direction is coming from this evening. Now around low pressure, winds are counterclockwise. So around this large area of low pressure, winds are moving counterclockwise. Again, winds coming from the south, southwest, out ahead of this system into Iowa. So if winds are coming from the south or southwest, we would probably expect temperatures to be somewhat mild. And in fact, you see here on the surface what we call a warm front. And this warm front will continue to move to the northeast. Well, let's go back to the satellite imagery. Now again, here's the loop of the infrared. Now what we mean by infrared, these clouds, these high clouds, as indicated by the whiter shade, are emitting infrared radiation. The satellite that is in geosynchronous orbit with the Earth is picking up the emission of the clouds. And so the higher clouds are typically indicative of colder clouds, and these lighter colored clouds here are probably what we would call low to middle clouds, because they're not as white as these here that I'm showing up here in the upper Midwest, or certainly not as white is the clouds we see down here in the desert southwest. Now, water vapor, again, this is the Unisys site. Water vapor looks somewhat similar to the infrared satellite imagery. However, the features are a bit more striking in the water vapor loop. You will notice areas of darker color and lighter color. The darker areas correspond to drier air. The lighter colors correspond to moist air. You can also pick out circulation features in water vapor imagery, and we'll talk about later why circulation features are so critical to forecasting the weather. But one of the first features that catches my attention is this dry air that's moving off of the Rocky Mountains across Kansas and into Missouri. But notice right behind that dry air we begin to see some very moist air beginning to move into areas of southwestern Kansas, up into the Dakotas, Minnesota. We have a little bit of moist air over Iowa too. Also notice this area back here in the Pacific Northwest. I'm going to take the cursor and I'm going to show the motion of the water vapor. Notice that we have kind of a counterclockwise turn to the features, or at least to the water vapor imagery. This is indicative of what we call low pressure. Recall that winds around low pressure are counterclockwise. So we have a low pressure area that's showing up here, or at least the circulation pattern of a low pressure area here in water vapor imagery. You don't need to worry so much about that. The thing that I want you to get from this particular image is that the lighter or the wider areas indicate moisture and the darker areas indicate drier air. So we see quite a bit of moist air back to our west, moving into Iowa as we go through the next day.
Now let's look at the third type of imagery, satellite imagery. So far we've looked at infrared, and keep in mind that infrared satellite can be viewed 24 hours a day. It does not rely upon sunlight as a source of light, and water vapor can also be used 24 hours a day because we're talking about in terms of infrared imagery and water vapor imagery. Those are available 24 hours because they do not require sunlight as a source point. Now, the visible satellite, which does use the sun as its visible point, is actually very interesting. With visible satellite, you can see the individual features of thunderstorms. And so what I've done here at the Unisys site is I've pulled this up. Let's see if I can make this larger. Now, visible imagery is only available during the day because it uses as a light source the sun. Now, you'll notice right here, if you use your imagination, you can see this swirling counterclockwise circulation over Iowa, or just to the north of Iowa. And then you see the clouds stretching down to the south and southwest. This is indicative of a front that has moved through Iowa. And you see these individual bright bands of clouds. These are thunderstorms. You can actually see the individual elements of each storm. And you see some of the brighter cloud cover down here over the southern states, the Gulf Coast region, Louisiana. And you can actually see a counterclockwise swirl. So there's precipitation occurring here, a lot of cloud cover. And the brighter the clouds are, that means higher clouds, and so we're talking about thunderstorms. And then you see basically just some low clouds here, but not a whole lot back here. It's pretty clear back here in the western portion of the U.S. So the visible satellite, which is available during the day, gives us a great feel for the individual convective elements. We look back here at Mexico. These are all very small storms. And if I continue to try to increase the resolution, it gets a little bit pixelated. But again, you can see these individual thunderstorms down here in Oklahoma and Texas. And in fact, let's just pull up a radar shot, and I can show you that feature back there. Radar data here. There you go. You see those individual elements down there, those thunderstorms that we saw from the visible imagery, and also down here over the Gulf Coast, Louisiana. Again, we see strong storms. But you look back to the west, the western portion of the U.S. did not show any clouds, and therefore no thunderstorms. Notice some here along the Rockies here, and some exiting off into northeast Iowa. Now, we can also actually look, and I'll talk about this here in a moment, about animating satellite and what we're looking for. If I just go ahead and animate it, we can see how the storms are moving.